Session on 3D modeling, the Philips approach. I am Diana Bardo from Phoenix Children's Hospital, and we have a panel of 4 speakers this morning. And then we have additional speakers to join us for a panel discussion at the end. Our speakers this morning include Kevin Love from Philips Healthcare, Dr. Solomon Dadia from Tel Aviv Medical Center in Tel Aviv, Israel, Justin Ryan from a research scientist at Phoenix Children's Hospital, and myself. We will be joined afterwards for our panel discussion by Dr. Amir Sternheim from Tel Aviv Sarsky Medical Center and Dr. Richard Tobin, who's chairman of radiology at Phoenix Children's Hospital. We're going to begin with Mr. Lev.
Thank you, Dr. Bardo. Let me bring up the presentation. No, it's fine. Here we go. Close that. Okay. Good morning, everybody, and welcome. I hope this will be a very exciting session. It affords the opportunity to see care pathways that we don't necessarily always see in a lot of the sessions at RSNA, and I think it's an incredibly exciting place for Philips to be in particular. The talk that I'd like to give this morning is a little bit about explaining, first of all, Philips's position in this area and the notion of trying to balance work or flow. When it comes to 3D modeling in particular, particularly those of the types of models that hopefully you're going to see in the next hour and a half or so, there's a lot of extraneous work that needs to also be done that might not necessarily be in our standard or more common workflows. And I'd like to explain the Philips approach of what we're trying to do to try and balance the needs to get a very good model and also to make sure that it's not a tremendous amount of work for the radiologist as well. Let me first explain and give a quick sense of how this fits into our overall strategy as a company, as Philips. So this is a snapshot of our strategy. It gives a sense of where we are going as far as healthcare enterprise informatics is concerned. And one of the issues that we look at as Philips is to always go beyond the image itself and to try and give a sense and give the opportunity for our technologies to span the entire healthcare continuum, not just within imaging, not just within advanced image processing, but from healthy living all the way through diagnosis, maybe prevention, and going all the way through to treatment and home care as well. When we think about what we can do as radiologists, so the value of the radiologist is not just within the reading room. And even within the reading room, we have a lot of technologies that we are bringing to bear with adaptive intelligence technologies that are trying to enhance the efficiency of what we can do in the reading room, but try and step well beyond that and have the opportunity to influence patient care and influence what goes on in the surgical suite and even beyond that as well. So this fits very, very well with where it is that Philips views itself as a company, with the types of solutions that we would like to bring to bear, and with the deep partnerships that we have with places like Tel Aviv Sarsky Hospital and Phoenix Children's as well, where we're able to bring that to light and make these concepts tangible in the most real sense. So just to set a very quick baseline, these are a couple different 3D printed models. I'm sure you've seen a lot of them around at various different booths. And what's amazing about them is that the level of complexity that we can get to today with modeling is incredible. The different types of textures, colors, the sorts of materials that we can play with give us an ever-increasing sense of reality when it comes to trying to adapt to what the patient needs and patient physiology might be. Okay? Actually, we can get down with the printers to the level of about 17 microns, which is even better than we can get to with a lot of our imaging technologies as well. Okay? And how do we do that? Well, we have, there's a lot of different printing companies out there. We'll talk in a little bit about 2 different printing companies that we have aligned ourselves with and the reasons for why. What you can see up on the screen is a Stratasys printer as well as a 3D Systems printer. But there's lots of different partners that we can also partner with. We've had the great pleasure of working with a smaller company, but one that actually knows their stuff very well, company called Synergy, which has also helped us to better understand the entire workflow. And some of the Synergy people are here in this room. You can speak with them after the show as well. So there's lots of different potential solutions that can be had. A lot of the discussions that I remember from last year's RSNA dealt with how to set up a 3D printing lab within the hospital. And the question that we asked ourselves coming out of last year's RSNA is, it's great if you have the opportunity, if you have the financing and the management capabilities to manage a 3D printing a service within the hospital, but not everybody has, and obviously that would most likely be the most ideal approach, but not everybody has the financing, not everybody has the wherewithal to be able to do that. And that's one of the things we challenged ourselves to think about. How can we help address that so that amazing technologies such as the ones that you're going to see make their way into a greater subset of the radiology community and the hospital community. So just to give a very quick sense, I wanted to give you a very, very rough overview of the basic workflows that you need to do in order to get to a 3D print. Many of you are familiar with this from many other talks as well. You start out basically with doing the imaging, CT, MRI, or ultrasound, or any volumetric imaging where you can get basic DICOMs. You would be able to convert that to a DICOM to imaging that is standard imaging. We would then have to segment the image, so you can't just have the 2D images. Remember, we're all talking about 3D models, of course. So you need to segment them into 3 dimensions. And then you have to create a printable model. The most common form, but not by any stretch of the imagination the only form, is an STL, which creates a mesh around the segmented model. You then have to combine those meshes. There's lots of questions about the mesh and the mesh quality and how you get it to mirror or mimic the physiology as much as you can. You would have to combine various different sorts of those files because each STL represents a single texture, a single color, and a single component of the anatomy. And then only then would you be able to 3D print the anatomy. So, we believe at Philips that there's a lot that we can contribute from an industry perspective to this entire workflow. Well, if you take a look originally, Philips already has a very strong presence, and the imaging modalities have a very strong presence in the acquisition of those images, trying to get as good images as we potentially can, and trying to put them into communicatable standards. But we also have advanced visualization platforms, and those advanced visualization platforms, such as the IntelliSpace Portal, do a lot of the things that you would need to do in order to be able to get along the workflow. So from an imaging perspective, we actually have within our repertoire already today a lot of the technologies necessary to get to the end item for a print. So where's the challenge? We'll talk about that in just a second. And just to give a sense for those people who do not or might not necessarily be familiar with the portal, I'm just showing a very brief overview of one of our applications. This is the Advanced Vessel Analysis application. So for us, whereas you might not necessarily be looking at 3D images in everyday packs or in a lot of the imaging that we're looking for in many of the sessions, we think in 3 dimensions with our advanced visualization capabilities. We're not the only ones, obviously, but that's what we do on a day-to-day basis. Think volumetrically, think in terms of what would be necessary for the patient. And this is just an example of the many applications that we have that do this. So if we talk about a couple of the potential benefits of 3D models, I'm not going to spend a lot of time on this. I'm sure a lot of people are already very, very well aware of this. It's potentially has a lot of impact in pre-surgical planning, in clinical training, patient education, and even going all the way down so far as having custom-printed orthopedic, not even orthopedic, but stents, parts, grafts, and patient-specific instrumentation as well. And there's a couple different examples that you can see about how we can really tailor these sort of technologies to the specific patient that we're looking at. By the way, just if anybody wants to raise their hand, can anybody point out a problem with one of the pictures that I've posted here as a challenge to the group? Anybody? Okay. All right, I'll say it anyway. The far left image, by the way, where they're doing a brain plate, is an image that you wouldn't necessarily have a full plate to be able to do that. For issues of heat exchange, if you're going to be able to do a plate in the brain, you need to be able to print out a meshed version of something that actually mimics the patient's anatomy and not. But just to give a sense, these are the sort of nuances that we have to understand when we're printing out components, and it's not just being able to create a file, it's understanding the physiology and how the materials that we might have might interact there. I think that's much further down the line, but these are the sorts of things that can be done with 3D printed models and with 3D imaging. And by the way, there's a lot of clinical evidence that's beginning to support the usage of 3D printed models, and this is just 2 of many examples. There was an article that was published last year that I think did a survey of over 487 different published articles that took a look at the economical benefit and the operational benefit of using these sort of technologies. These are all anecdotal for the most part. I know there still has to be a much larger trial to look at it more systematically, but there's a lot of evidence to start to suggest that there's a lot of benefit to looking at these models in addition to the case-by-case benefit, which we're going to have the chance to see in later presentations. Okay? Of course, this growing body of clinical support, of course, since this is a newer technology, has been growing rather exponentially over the course of the last couple of years. If I take a look at just the last couple of years, I mean, there was very little publication on this until very, very recently. But then it's really shot up. And if I only have the graph as of 2015, but if you take a look through 2016, 15, and 16 and 17 as well, the graph continues to grow at a very exponential rate as people are starting to look at these technologies very, very seriously and use them operationally. If I take a look at the installations of some of our partners like Stratasys and 3D Systems last year, at RSNA last year, relative to the installations that they have this year, you can see that they've also grown commensurately as well. So there's been a lot of recent developments in radiology beyond just the publication as well. There have been many major conferences related to 3D printing. There's a couple different conferences that are sponsored by individual institutions as well, but there's pan-institution conferences that we're starting to see that integrate also people from the industry, and this is one of the largest ones that happened actually just a little bit earlier on this year in the United States, and I think it was in San Francisco, where there was a very large representation, I think one of the largest ones that we've seen, taking a look at how we can apply these technologies a little bit more broadly. Of course, there's a growing interest in the radiology community as well. There's a special interest group within the RSNA that looks specifically at these sort of issues, both operationally as well as from a policy perspective on how to use these technologies. And Justin is a good friend also, is very involved in these groups, and I think there's over 300 members now. Is that correct? Over 300 members in this individual growing radiology community as well. Of course, we're also starting to see the beginnings of the first guidebooks that are presented, that are being published. This is one that I just happened to see that was published just this year in how to use 3D printing technologies as well. And of course, the FDA has taken a very keen interest in all of this as well, taking a look and trying to publish initial guidelines about how to use these sort of technologies. They themselves are looking towards industry to help give greater insight into how to set these sort of standards. But I mean, you gotta hand it to them. They must be excited about it if they're printing out their own FDA logo in 3D print as well and putting it on their website. Okay? They've published a little while ago an initial guidance, which I think is going to go through a revision as to overall guidances in terms of how to use these 3D models. Unfortunately, what the guidance does do is take a look at more of the safety aspects and a little bit less of the operational aspects of how to use that. And so it's a question to us as to how do we operationalize this and make it as operational as possible. Which brings me to the concept of the value chain. Okay? And herein, I think, lies one of the greatest challenges that we challenged ourselves to look at a little while ago when we thought about how we can bring these sort of technologies and modeling concepts into applications like the IntelliSpace Portal. So this is the way that we kind of mapped it out, taking a look at the value chain, where you would start with tailored protocols, looking at medical imaging. You would have to do some form of data manipulation as well. Whenever you get the images in DICOM, you would also have to change them somehow, smooth them somehow, or make them optimized for printing. You then would have to put it into some form of print prep software. Okay? Each one of the individual vendors has preparatory software that optimizes the model for their particular printer. Obviously, the physical printing. Then the post-processing, whenever you print a model, it doesn't just come out as beautifully as this from the printer. There's actually quite a bit of post-processing that needs to happen in order to get it to